Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to just do some examples of problems that you'll see on the Chapter 3 test. So these are just a random sample in no particular order. So let's just jump into it. So one of the things that you're definitely going to have to do is solve these systems of inequalities. And I think this one's kind of tricky, and honestly, if you can understand what functions these are, then you probably could kind of do any of these. So first I want to just say what three inequalities these are. So let's just take the blue one first. So we have a vertical line at -3, but it's a dotted line, so that would just be greater than -3. The green one is a absolute value, and it's going to be a greater than also because it's shading above, and it's shifted over a half and then up 2, and the slope is just like 1 here and -1 here. So there's no like stretching or compressing going on. So we would just say y is greater than absolute value of x minus a half and then plus 2. And the last one's kind of the weird one. So this thing has like a step kind of structure to it, and it does the weird kind of absolute value v thing though. So it looks like a absolute value and a floor function stuck together, and then it's also, like if we think of our normal, I'm going to get rid of this in a second, but our normal floor function is just that. So it's basically been shifted up 2 units there. So if we take all that together, we have y is like less than, because it's below, a negative absolute value of the floor function of x and then plus 2. So negative because, it sort of steps down. Absolute value because it looks like an upside down v, and the upside down part, I guess, is the negative part there. And then it's shifted up too. So a lot going on. So those are the inequalities. And then the second question here, so all of this is kind of question 1. Question 2 says, what is like the solution to this problem? And the answer is there's no solution, because this is dotted and this is dotted. So they're both in the blue area, but they're not gonna ever like all three intersect because it touches right there. And so you don't have any overlap. This dotted like region is not, part of the solution for this green one, and this dotted part is not part of the solution for the red part, so they actually don't overlap at all. All right, so another really important topic from this unit is the system of equations. So I'm going to do it by hand, and that's what I would want you guys to be able to do. But I also will show you what the RREF would give me for like the matrix problem, and that will be like a really good use, really good to do to like check your work basically. So I would personally do substitution here. So y equals -5 minus 5z plus 3x. Then I'm going to plug that in to the first equation. And then we can go ahead and simplify all that. All right, so that's one of them. Now I'm going to plug the y expression into the third equation, So negative 4x. And then I'm just going to distribute the 2. Okay, so then I would look at these two like blue circled equations, and I would just think about what technique I want to do here. So these are actually pretty nice because there's like a negative 9z in both of them. So I'm actually just going to call this equation 1, equation 2. And basically I'm going to do equation 1 minus equation 2. And if I do that, I would get... I get that because the z's would cancel, right? And so actually we know then x is negative 2. So now that's kind of the hard part. Now the rest of it is just like plugging things back in. So I would probably plug, I don't know, both of these two equations like about the same. I'm just going to plug in to this one because it's right here. So 2 times negative 2 minus 9z equals 23. So then negative 9z equals, 23 plus 4 would be 27. So z is negative 3. And then you have to take these two and you have to go like back up here. So if you do that, you can get y equals negative 5 minus 5 times negative 3 plus 3 times negative 2. And if you solve all that, you'll get 4. So that means the answer to this thing, these three planes intersect at negative 2, 4, negative 3. That would be the answer. And if you go and plug them in to the matrix and you do the RREF, you can check your work and you'll see that you really do get a matrix of negative 2, 0, 0. Oh, wait, sorry. I was reading this wrong. You get 1, 0, 0, negative 2. And you get 0, 1, 0, 4. And then 0, 0, 1, negative 3. And what that means is, 1x plus no y plus no z is negative 2, and blah, 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 blah. So this is like a really good way to check your work for these kind of problems. All right, so another thing you want to make sure you know how to do is just like kind of the basic arithmetic with matrices. So I could ask you something like this, like calculate minus 3b minus 2a. And minus 3 times b would just literally be 3 times every part in there. So you get this. Then 2 times a would be 6, 0, negative 2, 10. And so then if you subtracted them, you just subtract part by part. So 0 minus 6, negative 9 minus 0, and so on. And you would just get negative 6, 9, 8, and negative 13. So that kind of stuff is important to know, just like how you go and multiply numbers in and do addition, subtraction, that kind of thing. Down here, this is what I was sort of saying we're not going to worry about right now. So you can multiply matrices like this. So as long as, so this is a 2 by 3 matrix, and this is a 2 by 2. And you can multiply matrices as long as, like let's just say you have m by n, and then you multiply it by like, I don't know, n by, I don't know, L or something. But as long as these two things in here are the same, you can multiply those matrices. And there's a lot to be said about what that means, and that's the part that I'm sort of saying, like, it's really best for a linear algebra class to talk about that stuff and not an Algebra 2 kind of class. So basically wait a few more years if you want to learn about this. I am happy to talk about it with you, of course, but it's kind of beyond the scope of our class, to be honest. So you can do this, though. Specifically in this problem, you actually can't do A times B, because you can't do a 2 by 3 times a 2 by 2. So AB is actually undefined, but you can do B times A. If anyone is curious, you would get 6, 3, -3, -4, -7, 3. But you don't really need to worry about this. This kind of stuff, definitely need to worry about. You'll see that. You won't see multiplying matrices. So again, up here, this was just another problem. I just kind of want to show you that this is a thing. So you will, if you continue taking a lot more math classes, see problems where you'll be asked to do things like A cubed, and it literally does just mean A times A times A. But it is not part of what I'm going to talk about today, because it's along the lines of like the matrix multiplication like this. But this problem down here, I do want to do. So this is just a good kind of like concept question. So it says, what values of A with the following system of equations have an infinite number of solutions? So you basically want the case where, you have like a line, and then you have the exact same line right over it, and then you're going to get infinite solutions. You can see that, like, to go from 2 to 6, right, you multiply by 3. -1 to -3, you multiply by 3. And so this is almost just a scalar of this line, so they're almost the same thing. You just need to make this fit with those two that pattern over there. So we basically need, 8 times 3 to equal 4A, right? And so we just solve this for A, we'll have our answer. So you could divide by 4, and then you get 2 times 3 needs to equal A, or just 6 is 8. And that would be it. That's just if you go and like graph it, this being 3 times as big as this line in every term, then would just do nothing new, and it would just give you a case like this picture, and you would just get the same line right on top of itself, and so you get infinite amount of solutions. Remember that it's not all real numbers. It's just infinite because there's technically an infinite amount of points on the line like this, but there's definitely points like out here that are part of the real numbers but not part of the solution. So it's just infinite solution. Don't say all real numbers. That is a big difference. All right, and another thing that you definitely want to know how to do is solve these system of equation word problems. That was like another big part of this unit. And so I just want to go through this example. So any of these word problems, really, any word problem in math, I always just take it and just try to split them up into different like facts about the math. So, one of the first things I'm seeing, so I always try to figure out what question I'm trying to solve first. So this question is, how many puzzles did I solve each night? So it looks like there's 3 nights, and so I'm going to probably have like, I'll let like X be the number of puzzles solved on the first night, and then I'll let like Y be the number of puzzles solved on the second night. Don't know if you've ever seen that trick, but that's a really quick note-taking thing. The like little double lines mean it's the same word as above. I guess I could have done it there too. But basically, number of puzzles solved first night, second night, and third night is like X, Y, Z. And then, now I just kind of go and I just take each sentence and start breaking it down into equations. So I know that over the last 3 nights, I have solved 96 of them. So if I just add all 3 of these, I get 96. And then I have this part here that on the second evening, I solved 2 times as many twisty puzzles as the third evening. So that means that y would equal 2 times the number I solved on the third, which is just z. Then, let's pick a different color. So on the third evening, I solved 8 fewer puzzles than the first. So that would mean that on night z, it is the first night, x, minus 8. That would be 8 fewer than the first night. So that's my equations. And then let's just solve it. So I would probably go and take y here and plug it in up there. So I'm going to get x plus 2z plus z equals 96. So then x plus 3z is 96. You can also now take this and plug it in over here because you have what z is. It's kind of a good case for substitution. So if you go plug that in, and if you just distribute that and solve, you're going to get 30 for x. And then that means that, so what I would probably do is I would take this, plug it in right here. So then, z is going to equal 30 minus 8, which is 22. And then I would take that, and I'd go plug it into my first, no, sorry, I wouldn't do that. There's a better one. I would just go plug it in right there. So then y equals 2 times 22, which is 44. So I basically solved, what did it go? 30 the first night, then followed up by 44, a busy night of solving twisty puzzles, and then 22. I must have been kind of tired. But those are the x, y, and z values that make this system true.